Hello all, welcome to this online recording sessions in data science. So in this Python session, okay, so we are going to see modules. Okay, so what are modules and what are packages, what is their role in Python, so how it is helpful to us, all those things we will be discussing in this session. Okay, first, what is module? Okay, module is nothing but a partitioning of a programming into individual. Okay, partitioning a program into individual components is called modularity or a module. Okay, so we will be partitioning a code. Okay, so why it is necessary to partition the code? Does it really need it? Means I can say yes. Okay, okay, instead of writing everything in the same page or in the same file, if you write in the segment wise, okay, then that will be a better approach for a programmer. Okay, for a usage also it will be better. Okay, yeah, these are the benefits of partitioning a program. Why we need to partition it, why we need to segregate into modules. Okay, instead of writing all the functions, all the variables and all class, all the everything in a single file, we will be partitioning. Okay, so why it is partitioning is necessary? It reduces complexity. Okay, complexity reduces to create number of well-defined documented boundaries within the program. Okay, to define good boundaries. Okay, its contents can be reused in another programs. Okay, so instead of set up in my file, imagine there are 100 lines of code. Okay, there may be functions, variables, classes and everything, 100 lines of code. Okay, if I want to use some segment, okay, from those 100 lines, if I want to use some segment or some portion of a code into another file, right, into another file. Okay, in that case, what I can do, what is the best approach to do like this? Means I can say creating modules. Okay, so in that case, this module concept plays a key role. Okay, it will help us during that time. Okay, yeah, Python module is a file .py file, okay, containing variables, class, definitions, statements, functions related to a particular task. Okay, module consists of all these things. Okay, and this module file extensions will be .py. Okay, in Python we have two extensions, .py and .ipynb. Okay, so ipynb is a integrated Python notebook. Okay, NB means notebook. Okay, this is used for just read and refer. Okay, generally you've seen Jupyter Lab in Jupyter Notebook. Okay, in Jupyter Notebook mostly the files will be in the form of ipynb. Okay, we will just open it, write some code and just refer it. Okay, okay, those are ipynb files. But what are .py files? .py files are very powerful files. Okay, in Python. Okay, they are used for deployment. Okay, deployment. Okay, deployment of models like machine learning models, deep learning models. Okay, so if you want to transfer anything data from one place to another, so in that case we need to have a Python extension as .py. Okay, so .py is a powerful extension in Python file. Okay, so you can save it any one of these two. Okay, Python file extension can be file name followed by this extension. Okay, okay, so just remember the scenarios according to your convenience, according to the usage. You follow the extension. Okay, yeah, using help function we can know about the module. Okay, so what is module and all. Okay, so you can see this. Okay, help function, what does all it mean? Okay, yeah, so this is importing modules in Python in programming. Okay, so Python provides import statements. Okay, to import entire module you need to use this statement, import module. Okay, module name. Okay, to import selected objects. Okay, we have a module, right? So in that module, if you want to select a particular variables or particular functions or particular methods. Okay, so in that case from module name import object. Okay, so this is the syntax for importing a particular selected object, okay, from a module. Yeah, so if you want to import entire module, then this is the case. Okay, this is one of the example. Okay, so import math. So in that we are writing some code, and then we are trying to import it in another file. Okay, so this we will see with the help of in practical. I'll just show you, taking one or two examples, what is module and how does it works. Okay, yeah. Yeah, next we will create a module and importing it in another program. Okay, this we will see it. Okay, so here is just a program. So we are taking one, we are creating one file. That file name is factorial.py. Okay, so in that file we are having this code. Okay, and next I'm creating another file. That file name is factorial_1.py. okay, so in that I am writing this lines of code. Okay, so now if I execute this, this file will be also integrated into this file. Okay, so those lines that are files, those set of lines that are present in this file will be used in this file. Okay, yeah. So I think let us see the practical approach so that you will understand the better way. Okay, so I'm just going to my downloads. Here is my downloads. Yeah, let me find one program. Yeah, so I'm just opening it. Okay, right click, open with Python. Okay, so instead of command prompt, let me open from this. Okay, this is ideally. Okay, so we are doing this module concept in ideally. Okay, so I'm just opening the ideally, Python ideally. So this is a welcome page that you get. Okay, this is a welcome page that you get. Okay, so now I want to open one file. Okay, open. So from downloads, I'll pick one file which I have already created for you. Okay, yeah, so I have opened this file. So I'm just running it. Run module F5. So it is asking enter any number, enter the number. So I am entering 8. So 40320. What is this 40320? It is the factorial of a 8. Okay, is it correct? 40320. Okay, okay, fine. Let me run one more. So you can click F5, enter the number 5. Okay, 120. Okay, 5 factorial is 120. Okay, so in this way, you see, if I'm executing this file, I'm getting this output in the output window. Okay, 120. So what code I have written? If you observe what code I have written, please see in this my code file what code I have written to execute this output. So I have just written 4 lines of code, right? So how many lines of code I have written? I have just written 4 lines of code. Okay, to see line numbers, you need to just select it, go to options, configure ideally, show line numbers. Then you will be able to see line numbers. Now you tell me how many lines of code I have written? 4 lines, right? So with these 4 lines of code, I am able to get the output. Okay, 5 factorial, 8 factorial, or whatever it may be. Okay, so now I think it is somewhat smaller, right? So if I want to increase the font size, what can I do? So I can go to options, configure ideally. So here I can go to size and I can click 20. Okay, so here you can change the font faces also. Okay, you can put to Times New Roman, Georgia. Okay, so what are the Times fonts that you like? You can choose from here also. Okay, okay. So right now I'm going with the default one only, but I'm just applying it, the font size as 20. You can put bold also, no issue. Apply. Yeah, okay. So now you see the size of my code got increased, right? So just once explore all these features in the ideally. Okay, ideally stands for integrated development environment. DL means development, E means environment. So it is one of the IDE. Okay, it is one of the IDE that I am using. So ideally is one of the IDE, okay, that I am using. This can be very helpful in case of offline. If you don't have any internet, then you can go with this or Jupyter Notebook or Jupyter Lab. Okay. Yeah. So now if I run this, what I am getting, I'll run it again. So I'm entering again 8. So 8 factorial is this one. Okay. So in this way you are getting factorial. So what I have done actually means I'll show you. Okay. So I'm going to my downloads. So this is the program that I have written. Okay. This is a program that I have written. What program? Yeah. This is the actual program. Okay. In this program I have written a program for getting a factorial of a number. See, def fact in, so f equal to 1. Okay, starting from 1, you can see all this code, factorial of a number, logic I have written here. So I have saved with the file number what? Factorial.py, right? So using factorial.py I have saved this file. Okay, so in next file what I am doing, import that file name I am giving here. Okay, that file name I am giving it here. Okay, so that file gets imported here. Okay, so here what I am asking, x is equal to int input, enter the number, y equal to factorial dot fact. Okay, factorial is the file name, fact is the method or function present in it. Okay, method or function that is present here, fact. Okay, so factorial dot, what I am using, factorial dot, factorial is the file name, fact is the method name or function. Since it is outside the class, I am calling it as function. Okay, in that function I am putting this variable what I am entering. So print y. Okay, so this is the logic. Okay, so this is how I pulled that file logic into this file using import statement. Okay, this is nothing but a module. Okay, so that module I am trying to use it here in another module. Okay, in this way I am trying to communicate between two modules. Okay, so next I'll close this file. I'll open one more file. Open. I'm going to downloads. So I'm going to open this file. Okay, so now you see this code. What is this code? It is just it is a code or a module. Okay, it is a code, just only code, right? Just code in the file name temp underscore conversion. Okay, temp underscore conversion is a file name. In that file name, so I am just writing some logic, conversion between Fahrenheit and Celsius program. Okay, I am not using any import. Okay, so now I will use this set of code in another file. Okay, so let me open another file where I'll be using it. Yeah, so I'll be using it. Okay, so I'll be using it. So for that, what I need to do, import file name. Okay, import file name. So you can write some logics if you want. So I am writing c equal to float for giving an input. Okay, so I'm putting some result, then print result. So run. So for running, you can run module, or you can use F5 also. Enter temperature in centigrade. So I'm putting 50 degrees centigrade. So then it is 120 Celsius. Okay, so if it is in I think 122 Fahrenheit. Okay, yeah, if I'm giving in centigrade, I'm converting into Fahrenheit. Okay, so this is how you do conversion from Fahrenheit to Celsius. Okay, so similarly you can do for this one also. Fahrenheit to Celsius is this function, right? Then Celsius to Fahrenheit, this function works. Okay, so you can design in the in the file, okay, where you are trying to import this set of file, okay, you can design in that way. So this is how module works. I hope you understood, right? This is how the module works, and there is an advantage, right? We are moving for logic from one file to another file. Yeah, now let us see what is package. Okay, okay, so now what we have done in module, so we have created one file and we try to fetch this logic into another file. So this is module. Okay, so now we are trying to use package. Okay, yeah, so before starting that, let me give brief points about this module. Okay, so the module that we have created is a user defined module. Okay, so user defined module means you can create our own module like I have shown. Okay, so writing and importing. Okay, so we have also inbuilt modules. Okay, inbuilt modules where you can perform some operations. So in Python software only, some inbuilt modules are also there. Okay, so that you can use it. So some of the inbuilt modules, let me show that also. So let me show some inbuilt modules that we have. Yeah, math module. So math module is a inbuilt module, inbuilt module. Okay, so directly we are going to use import math print. Okay, so math is a function. Okay, so math performs some function. Okay, so that I can directly import. I'll be not creating it, so it is already present. So all the modules are present inside the Python. So I can use import. Okay, so floor, cell. Okay, so these all are functions that can be used from math module. Okay, so math.pow. Okay, so from math module we can import power function. Okay, and you can perform power. Okay, math.fabs. So math, from math module we can import. So all these are inbuilt. Okay, so random module, we have random module also. So okay, statistic module also, where we can perform mean, median, mode. Okay, import statistics. That means statistics module gets imported. Okay, this statistics is inbuilt one. Okay, so these are inbuilt ones. Okay, so these are inbuilt ones. So but what I have shown just now, user defined. So user defined modules that we have seen. Okay, yeah, so this is all about modules. So now let us talk about packages. So what are packages? How we need to create packages? Okay, so let us see it. Yeah, packages will be same like a modules. Okay, so we'll be creating modules. Okay, so this is module 1, module 2, module 3, suppose, imagine. Okay, so to this module, if I want to combine all these modules together, and if I want to create a package, so we have seen packages, right? We will be getting with pip install, right? Packages. Okay, pip install numpy, like that we'll be getting, right? So those are all inbuilt packages. Okay, so but if you want to create a package, how do we create a package? Okay, so for that we need init file. Okay, so we need a one file, underscore init underscore, okay, .py file we need. Okay, so first, if I show practically, then you could understand better. Okay, so now let me show the output. Okay, directly the output, then later on let me explain. Okay, so I'll try to open one file open. Okay, from downloads. Yeah, so this is the file I'm trying to run it. Okay, so what happens, you see You see here also I used import, here also I used import. Okay, so that means two modules I'm trying to import in this file because import is there, right? This also inbuilt ones. Okay, so I'm just running it, run module F5. So it is asking some output. You tell me, do I have written all the logic for this? Okay, let me let us observe this. So it is asking some input, enter weight in kilograms. I am entering 5. So it is asking enter weight in ton. Okay, so I'm giving 5 tons. So it is giving 11.02 kilograms. Okay, so it is showing some error. Color is not defined, right? So let me remove this color. Okay, then again rerun it. Okay, so Control S. So if you are not saving the file, you could see the star mark here. Okay, so if you save it, that star mark will go. Control S. Yeah, so I am running it, run module F5, enter weight in kilograms, 5 kilograms. Okay, so 5 kilograms is 2.26 ton. Okay, okay, next enter weight in ton. So I'm entering 5 tons, means 11.025 kilograms. Okay, 11.025 kilograms, 5 tons means. So now enter dimensions to convert inches to feet. Okay, now this is another one, okay, now enter dimensions to convert inches to feet. Okay, this is another conversion I'm trying to do. So 1 for inches to feet, 2 for feet to inches. So let me select first option, inches to feet. Yeah, now it will ask inches. Okay, so how many inches? Say suppose 5 inches I have given. It will convert into feet and it will be 0.41 feet. Okay, so you see, if I am running this file, I am able to get these outputs, right? So in this file, what is happening? Let us try to understand. Okay, so we are using import statement. That means we are using one module that is already defined with file name conversion. File name is conversion. So in that file name, we have mass function. Okay, so sorry, mass file. Okay, so again in that mass file, we are having mass C. Okay, mass C is the function name. Okay, let me show that. Okay, let me show that, then you could better understand it. Okay, so this is the folder I have created. So first I have created one folder, that folder name is conversion. So in that folder, you observe I have created subfolders. Okay, this folder is for creating one module, this folder is for creating one module. So okay, I have created 2 modules. Okay, so this you don't need, but after running you get this file by default. Okay, for the first time if you are opening this file means you won't get that catch file. Okay, so if you already run once means you'll get a catch file inside this folder. Okay, you see this what I'm having length C file and init file. So it is 0 KB. So that means we need to have one init file in order to convert into package. Okay, in order to convert into package, we need to add init file into the along with the file that we want to create it like a module. Okay, so along with a module file, we need to create init file also and put it in one file. Yeah, similarly in mass folder also, yeah, see catch file I have run once. No, catch file is getting added into it, so delete it. Yeah, so in this folder what I'm having, in mass folder I'm having mass C file and init file. Okay, so what is this init file? It is an empty file. If I open, if you want me to open, I can open it, I can show you all. Okay, so in mass there are 2 files. If I am opening init file, it is empty. Okay, so if I am opening again mass file, you see. So I have written a code for conversion of kgs to tons, tons to kgs. Okay. So similarly, if I open another file from length, you can see one init file, empty init file, and one length file. In length file also we are having some code. Okay, let me open it. Yeah, for conversion of length feet to inches, I have written this. Okay, so now you tell me what I am doing now. Okay, what I am trying to do. In order to create a package, I need to use init function, right? So what are the steps that we need to follow? What are the steps I need to follow? Creating a package conversion which contains two different modules. Okay, two different modules. So one module is consisting of length.c.py and mass.c.py. Okay, in two different subfolders, length and mass. Okay, this is folder 1. Folder 1 name is length. Folder 2 name is mass. Okay, so in this folder I am trying to add mass C in the mass folder. Okay, folder name is mass, and length C in the length folder. Okay, so length C is nothing but it consisting of this code, which is capable of converting from one length to another length. Okay, so in mass C file you can see from kgs to tons to kgs I am having this code. Yeah, these are the steps. Okay, create a folder with name conversion. So first create empty folder with a folder name conversion. Next create two subfolders with length and mass. Okay, so in length folder you add length c.py. In mass folder you add mass c.py. Okay, along with init.py. Okay, so now you create another file, fresh file, and try to use this lines of code. Okay, so that is what I have done. Okay, so that's what I have done here, if you observe it. Okay, so what I have done here, yeah, print, yeah, this is what I have done here, import conversion dot mass c. Okay, import conversion dot, so this is what I have done here. Okay, so if I run it, run module F5, so again it will ask. So it is working fine. Okay, so this program is working. Okay, so this is how you create a package of your own. Okay, I hope you understood, right? I hope you understood. Yeah, so what is namespace and all, you can refer it. Okay, so this is how it looks. Okay, in folder we are having sub files, how it looks, and in another file how we are trying to use it. Okay, so these are some standard inbuilt libraries. So import date, time. Okay, this we will be not, this we need not create our own. These are all present inside the Python file. Okay, so that's it for today's session. So in this session we have learned how to create module and how to create package practically, and we have seen different types of modules and different types of packages also, right? Inbuilt packages and modules, use the different modules and packages, right? I hope you got some information, right? So thank you all. So thank you for giving this opportunity. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.